Alright, section 1-2 is on graphs of equations, and they're going to start out with some of our basic stuff as far as finding the graphs with some tables, determining if some points are actually solutions, and so on. The objectives of this section, you're going to learn how to sketch graphs of equations, going from very basic up to some other methods. You're going to learn to find x and y intercepts. We'll use some concepts of symmetry to sketch graphs of equations. And then we'll also find the equations of and sketch graphs of circles. And then we'll also use graphs of equations in solving real-life problems. Alright, so first thing, we have to determine if an ordered pair is actually a solution, or will the points actually show up on the graph. So the first one that we're going to look at is, we're going to take a look at this equation, y equals 10x minus 7. And you probably recognize this is in your form y equals mx plus b, so our point slope form. So we want to know if either of these points, or both, are actually on that line. Well, instead of taking the time to draw the line out and then seeing how accurate we are and seeing if those points are there, one way to find out if something is a solution is plug both values in, one for x, one for y, and see if it makes it a true statement. So let's do our first one here. So we'll start out with the original equation, y equals 10x minus 7, and substitute. Y is 13 for a, 10 times x, which is 2, subtract 7. And we're trying to see, is the left side indeed equal to the right side? So let's bring this down and simplify. 10 times 2 is 20. Subtract 7. 13 does equal 13. It's true. So that tells us that on this line, 10x minus 7, that 13 is actually on that line. Alright, let's check the second one here. We'll go back to the original equation. Substitute in our x and our y. So y is negative 3, x is negative 1. And again, we're checking to see, is the left side equal to the right side? So let's simplify on the right side. 10 times negative 1, negative 10, minus 7, and we get this. Not equal. So that tells me that this point is not on that particular line. So pretty simple. Substitute in x's and y's no matter what your equation is. If you get a true statement at the end, like here, we know that that point's on that graph. If it's not equal to each other, it's not on that graph. So pretty simple. Alright, one of the first ways that we've learned how to do graphing was doing our graphing by plot pointing, or point plotting, sorry. Basically, this is all we did. If we had an equation that had variables on one side, we tried to focus on the point of isolating a variable. Get one letter on one side, everything else on the equation on the other side. Go to an XY table. Plug in either x's or y's, depending on what's not isolated. Solve for the isolated variable. Then we're going to plot the points that we got from our table, and then we're going to connect the points to make a smooth curve or a line. So let's go back to one that was similar to the one that we just looked at. It won't be exact, but it'll be pretty close, where we're given this equation. Y equals 7 minus 3x. Well, if you remember from that last page, when we looked at this, first thing we wanted to do, try and isolate the variable on one side. Well, we've already got a y set up by itself. So since it's isolated, we can already go to our next step and just set up a nice xy table of values. So since x is within the expression on the right side, let's just pick some values. So let's go negative 3, negative 2, negative 1, 0, 1, 2, 3. You'll have to decide with different equations how many points you want to put in. Get enough points so you get a pretty good idea of what the picture is going to look like. So if we substitute in negative 3 here, I'm just going to get this. 7 minus 3 times negative 3. And if we simplify that, that's going to turn out to be 16. Negative 2 can go in. 7 minus 3 times negative 2. If we simplify that, we get 13. And just continue on substitution and simplification. So this is going to give us 10. If we plug 0 in, we just get 7. Plug 1 in, we get 4. Plug 2 in, we're going to get 1. Then plug 3 in, we're going to get negative 2. So these would be our values, our x and our y, x and y, x and y, and so on. So that gives us enough values that we can take this now and we can go and plot our points. So if we set up our xy axis here, a little crooked, but you'll get the idea. Let's see if we can move this a little bit to clean it up. That's a little better. That'll be good enough. Alright, so if we set this one up, we want to plot those points. So let's set this scale up going by 2's. So we'll have 2, 4, 6, 8, and so on. And this way, 2, 4, 6, 8, 10, 12, 14, 16. Alright, so this should fit. Let's actually go with this. Let's go with a scale of 1 on the x-axis, and let's go with a scale of 2 on the right axis. Or on the right axis, the y-axis, sorry. So our first one would be at negative 316. So 1, 2, 3 to the left, 2, 4, 6, 8, 10, 12, 14, 16. We went a little bit above our graph. Negative 2, 13. So 2 to the left, 2, 4, 6, 8, 10, 12, 13. So right about there. Negative 1, 10. So 1 to the left and 10 up. 0 and 7 from here. So we're about right there. And what do we have? 1, 4. So 1 to the right, 4 up. 2, 1. So 2 to the right and 1 up. And 3, negative 2. So we go 3 to the right and down 2. So this one, we actually lucked out. We're going to end up being able to connect those points and actually getting a pretty straight line. And again, that's a good thing because if you recognize the form, here's our mx plus b, which means it should get us a straight line, which it did. So again, pretty simple. Plug and solve, get your points. Okay? Alright, now another one that we can look at here as far as some of our graphing, let's do one that's a quadratic. And again, you've done this before, so you know what it should look like, but just so we can review it, x squared minus 2. Already got a y isolated, so that means we can jump right into our xy table. So let's pick some values for x. Let's go negative 2, negative 1, 0, 1, and 2. So again, if I plug negative 2 in, and again be careful of the signs, negative 2 squared minus 2, negative 1 squared minus 2, 0 squared minus 2, 1 squared minus 2, and 2 squared minus 2. So simplify each of our y values. So if I put negative 2 in here, negative 2 times itself is 4, 4 minus 2 is 2. Square negative 1, I get 1, 1 minus 2 is 1. Oops, negative 1. 0 squared is 0, 0 minus 2 is negative 2. 1 squared is 1, 1 minus 2 is negative 1. And 2 squared is 4. 4 minus 2 is 2. So there's our ordered pairs. Negative 2, 2, negative 1, negative 1, 0, negative 2, and so on. So let's take this one back and hit up a new graph. So we'll go from here. There's our y-axis. Another one for our x-axis. And then we'll just plot our points. So, oops, I gotta get back so I can draw my pictures here. Negative 2, 2. So 2 to the left, 2 up. There's a point. Negative 1, negative 1. So 1 to the left and 1 down. 0, negative 2. So now I'm right here. 1, negative 1. Right there. And 2, 2. Right there. Now this time it's not a straight line, so we're going to make a smooth curve. Or as smooth as I can make it on my pad here. And there we go. So there's our parabola. So again, isolate a variable, plug and solve, use the values that you came up with to plot your points, and that's going to get you the shape of your graph. Alright.